Good day, students. Welcome to part one of the Algebra 1 Common Core Regents examination for fall 2013. In this installment, we are going to be going over problems 1 to 5. All right, let's take a look at problem number 1. It says, which ordered pair is not in the solution set of y greater than negative 1 half x plus 5 and y less than or equal to 3x minus 2? So first thing you want to note is the word not. So which of these do not satisfy these two inequalities? This is a system of inequalities problem, and it can be done in two different ways. We can do this by graphing or by substitution. Okay. In this clip, I'm going to show you how to do both methods, and then you can pick the one that you like better. So method one is the more effective method, which is by graphing. Method one is graphing. We're going to go ahead and graph this system of linear inequalities and generate the solution region. Okay, method one is graphing. All right, so how do you graph system of linear inequalities? Where it's very similar to graphing a line. Okay, so let's go over how to graph a line first. So let's say you have y equals mx plus b. How do you graph a line? You know that m is equal to rise over run, and you know that b is your y-intercept. So where do you start? B, you can look at b as a word for begin. Okay, you always start from b. B is your y-intercept, where the graph cuts the y-axis. So that point on the y-axis is your y-intercept. That's the first point. How many points to define a line? You need 2 points. So to get to the next point, you just rise and run by the appropriate number of units, and then you find your second point and graph your line. All right, so when you're graphing inequalities, you also have to apply the effects. Apply effects. All right, so graphing inequalities. Now, what do I mean by apply effects? You notice we have greater than, less than, or equal to here. They're going to affect how the line looks like. All right, so let's just organize our inequalities. We have less than or equal to, greater than or equal to. Now, I'm going to make a grid. I'm going to group them like this, like this. All right. So what we're going to have here is, if you look at these two, less than or greater than, they do not have a line underneath them. Okay, so if they do not have a line underneath them, how does that affect the way the graph looks? It tells you where to shade. I mean, it tells you if the line is solid or broken. So if there's no line underneath, the line is going to be broken. And then these two, less than or equal to, or greater than or equal to, is going to be solid, because this line means the line is part of the solution region. All right? Now let's take a look at the up-down view. Let's look at the columns. What if an inequality is less than? What does that mean? It means you have to shade a particular area of the line. If it's less than, you shade down. If it's greater than, you shade up. All right? So these are the effects we're going to apply to our lines after graphing them. So if you notice, this inequality is greater than, so this one is going to be broken. Is this one right here broken? And we're going to shade up. This one is less than or equal to, is going to be solid, and we're going to be shading down. All right. Okay, so let's go ahead and graph our system of linear inequalities. I'm going to call this 1 and 2, so we don't get confused. Now, the slope of line 1 is what? What is the slope of line 1? So let's rewrite equation 1. We have y is greater than negative 1 half x plus 5. What is the point? The slope-intercept form for the equation of the line? Y equals mx plus b. The coefficient of x is your slope. So m is negative 1 over 2. What does this mean? It means that you have a negative rise, which means that you're going to go down 1, and you're going to run 2. This is your rise over run. Okay? Rise, which is negative, over run. And then our b is a constant you add into this term. This is where we're going to begin, which is 5, and this is our y-intercept. So this is for line 1. In order to stay organized, how about we go ahead and graph this first to refresh our memory on how to graph system of linear inequalities. All right, so set up our coordinate system. this All right, so for line 1, we always start with the y-intercept. So as we can see, our y-intercept is positive 5. So let's go ahead and graph that. That's 1 point on the line. 1, 2, 3, 4, 5. This is our y-axis, and this is our x-axis. Now what are we going to do? We need another point, because the line is defined by at least 2 points. So we're going to use the slope to find the next point. So negative rise of 1, go down 1, and run 1, 2. That goes another point. You can do it again, down 1 over 1, 2. The more points, the more accurate your line is going to be. Now, let's not be in a haste to graph the line. We need to take a look at the effects. Since it's greater than, that means it's going to be broken, and we're going to shade upwards. Okay, so let's keep that in mind. Broken and shade upwards. So we're going to draw a dotted line or broken line through these points. And I do not shade until I'm done graphing all the lines, and then I can just shade my solution region. Okay, so there goes the line. The direction of our shading is, it's greater, right? So greater means we're going to shade upwards, so in that direction. So this line is our first line, which is y is greater than negative 1/2 x plus 5. Now what's the next line we're graphing? Let's graph line number 2. Okay, line 2, this one right here, y is less than or equal to 3x minus 2. Following us, so let's write it first. We're graphing y is less than or equal to 3x minus 2. Now following our steps, we need to find the slope and the y-intercept. So to make it easier on us, let's write down the slope-intercept form of the equation of a line, y equals mx plus b. So we can clearly see that m is 3 and b is negative 2. So our slope is 3 over 1. So we're going to rise 3 and run 1. And our y-intercept is negative 2. This is where we're going to start on the y-axis. Now since we have less than or equal to, that means that it's going to be solid, and we're going to shade down. Let's graph it. We're going to graph it on the same coordinate system. So starting from negative 2, we're going to rise 3, 1, 2, 3, and run 1. All right, do it again. 1, 2, 3, run 1. Remember, the more points you have, the more accurate your solution is going to be. Okay, so let's go ahead and draw the line. This is y equals 3x minus 2. We're going to apply the inequality momentarily. All right, so there goes the line, and let's label what it is. This line right here is y is less than or equal to 3x minus 2. So this is less than. Now imagine this is a roof right here. Where's underneath the roof? If this is the roof, the rain is going to fall here, so this is less than. Okay, less than is underneath the incline of the line, so this is less than. Now there are 4 quadrants, 1, 2, 3, 4. Let me enumerate them for you. Quadrant 1, quadrant 2, quadrant 3, quadrant 4. Which one do you think is a solution region? Well, if you're behind any of these arrows, then that is not a solution region. Whatever quadrant you pick, both arrows must be pointing to that quadrant. Consider quadrant 3, for example. We have no arrows pointing here. So this is not, it's not here. This one we have only one arrow pointing here, the other arrow is not pointing there, so it's not this. Quadrant 2 has only one arrow pointing there, so it's not quadrant 2. It must be quadrant 1, but let's check. You notice we have two arrows pointing in quadrant 1, so we are confident that our solution region is this region right here. Now, you don't have to make a mess, just draw concentric lines to indicate your solution region. Alright, so this is where the solution is. This means that any point that falls on this line in this region, or this region, it satisfies both inequalities. So let's go ahead and graph our alternatives. So the first one was 5, 3. 5, 3, I'm going to graph them in red. 5, 1, 2, 3, 4, 5, 1, 2, 3. There's the first point. The next point, so let's write it there, 5, 3. The next one is 4, 3. 1, 2, 3, 4. 1, 2, 3. Right here on that inequality, 4, 3. That's an interesting one. The next one is 3, 4. 1, 2, 3. 1, 2, 3, 4. And then last but not least, 4, 4. 1, 2, 3, 4. 1, 2, 3, 4. Right here, 4, 4. Okay, and then this one was 3, 4. So which of them is not the solution? We can clearly see that these 3 points, 3, 4, 4, 4, and 5, 3, are in the safe zone. They are in the region. But how about this point in this inequality, on this line? The question is this line included? What does it mean for the line to be broken? Since the line is broken, that means the line is not included in our solution region. Okay? So we're going to eliminate option number. So basically, the question was asking for which one is not, right? So the one that's not good, this is good, right? 3 is good, 3, 4 is good, 4, 4 is good, this is bad, so this is the answer. We're looking for the one that does not satisfy both inequalities. Alright, so let's take a look at method 2. I told you that I was going to do this problem in 2 different ways. So method 2 is by substitution. Okay, method 2 is substitution. Now, what on earth does this mean? This means that you are going to substitute your answers, potential answers, into the question. Whichever one does not satisfy the inequality, remember the word not, whichever one does not satisfy the inequality is our solution. Alright, so what you want to note here is that we are testing 2 inequalities. Okay, so let's make a grid right here. Alright, so our first one is, we know that our coordinates are x and y, right? X, y. And then we're going to test y is greater than -1/2 x plus 5 first. If it passes that test, then we'll advance to y is less than or equal to 3x minus 2. If it passes both tests, then that is a solution set, and it's not our answer. So the first one we're going to try is 5, 3. Okay, what does this mean? It just means that 5 is x and 3 is y, as indicated up there. Alright, so we're going to plug it in this inequality and see, is it true or false? So the question is 3 greater than -1/2 times 5 plus 5? What just happened here? We took x out and replaced it with 5. We took y out and replaced it with 3. Okay, so let's go ahead and work this out. Put this as 5 over 1, and then we're going to multiply. Okay, so you have is 3 greater than -5 over 2 plus 5. How will we express 5 as a fraction? So we can combine these two. Now, how do you combine fractions? You find the LCD, multiply this by 2 top and bottom. So it's 3 greater than -5 plus 10 over 2 over 2. Keep on working. Is 3 greater than negative 5 plus 10 is 5 over 2. 5 over 2 is 1, that's 2.5, right? So it's 3 greater than 2.5. Is it? The answer is yes. So this answer checks out. What do we do now? We have to test the second one also because it must satisfy both. All right, so for the second one, we plug in y. Remember, y is 3. Is 3 less than or equal to 3? What is x? X is 5 times 5 minus 2. Is it? So we need to put question marks here because we don't even know yet until the end. All right, so there is 3 less than or equal to 15 minus 2. Is 3 less than or equal to 13? Is it? The answer is yes, so this checks out. So this is a solution, so it's not what we're looking for because we're looking for something that's not a solution. All right, so let's move on to the next one. Option number 2, 4,3. This was the borderline situation, the one that failed. That was on the inequality in method 1, right? So this one is our answer. We already know that, but let's act as though we don't know. All right, so we're going to plug it into the inequality and test it out. All right, so if we do it, we're going to have is y. What is y? Well, let's label it so I don't get confused. This is x and this is y. So the question is y is 3 greater than negative 1/2 times what is x? 4 plus 5, is it? So put this over 1. We're going to carry out the procedure, the arithmetic operations that we did here in this upper column. The same procedure will apply here too. So it's 3 greater than negative, multiply across, 4 over 2 plus 5 is 3 greater than negative 4 over 2 is negative 2. Negative 2 plus 5. And then is 3 greater than 3? Is 3 greater than 3? The answer is no, so this is your answer right here. So since this fails the test, we know that this is the answer. Now you might think, oh wait, this is much easier than the other method. The answer is not actually. What is happening here? What happened here is that we carried out our calculations correctly. If I made a mistake, let's say up here, it will appear as though this will be the answer if I made a mistake here. This method has a lot of room for error, so that's why you might want to shy away from it and use the graphing method. And also, it seems short. The reason it's short is because our answer is the second option. Let's say our answer was option 4. We have to do every single one completely in order to find the answer, and that gives you a lot of room for mistakes, right? So if at all possible, graphing is the safer method, but if you don't like to graph, then you can resort to using this method. All right, we're going to cut this tutorial short. Sorry about that. Please feel free to subscribe so you can get updates to the remaining parts of this review installment. Please post a comment to let us know what you think about this presentation. More clips can be found on mathcodeserve.com/testprep. Thanks again for watching and have a wonderful day.